Thank you. Good morning, everyone. I appreciate the opportunity to be here with you this morning. I looked at the website and information that Dr. Williams and his staff had provided me with to try to get a feel for what to present here this morning. To me, it's always a challenge. I'm an idea person. I play a lot with ideas and concepts, and so I'm always a little bit at a loss as to what exactly to present with people that would be interesting to them and allow me to be a little creative and have some fun with information that I'm dealing with in my world also. So this morning, when I looked at some of the reasons that you all might be here this morning from the, for this lecture series, I saw that you're looking for information about programs that we offer to customers, exposure to specialized techniques, and boy, we have a lot of specialized techniques. Also to accelerate your learning process, and also how society impacts the business and how the business might impact society, and also to give you a real-world perspective on the business, understanding that we're a small local family business that deals with an international clientele. So part of my agenda in being here this morning with you is obviously I like to brag about my business. It's a lot of fun. We do a lot of fun things. So I'll try to keep that to a minimum. But also I'm going to share insights and perspectives that you may find interesting or useful in other endeavors. So this isn't just a conversation about the specifics of die tech and the manufacturing world and the world of precision metal stamping. So what I'd like to do is during this presentation, if you keep in your mind what you might take away from this to practice in your own personal life, your school work or businesses you might be involved in now or at a future date. At the end, maybe we'll have some opportunities for you to share what you think you can take away from this presentation, what's been useful to you, so that it gives me an opportunity to learn and see if I've been successful in stimulating ideas and thoughts about the business community and all of you here this morning. So let's get started with a talk about a current state trend, reshoring. I'm sure all of you have, now the technology of the clicker, I'm sure all of you have heard about reshoring. Where do I need to point it?
I think if you hit this like this.
Oop. She said this one on the back here. Maybe I'll just click it here.
Oh, yeah, you can do this one.
There we go. So when we talk about reshoring, what I'd like to do is give you a little bit of a roadmap so you know where we're going. All right, because we're going to cover a lot of ground and move fairly quickly because our time's limited. So I'll start with some definitions and background, some choices that we've made as an organization, results that we've gotten, some analysis of those results, and then some bigger implications. What might be implications that are more germane to the activities that you're interested in and not specific to the world of precision metal stamping. So reshoring. You've probably heard a lot about it in the news. It would seem to be a recent phenomena for the play that it's getting. And a simple definition is it's bringing work back home is the way I look at it. A lot of this work that is being reshored or brought back to this country had been sent overseas, particularly to Asia and some other European countries, some of the less developed ones in the Slovakian regions, Yugoslavia, the former republics, Czechoslovakia. All the breakup created a lot of economic dynamics typically characterized as low-cost countries. So the big move to these offshore locations and outsourcing was to take advantage of this low-cost labor. The reshoring phenomena is a reversal of that trend, beginning to bring the work back to the United States. And there are a lot of factors for that that we'll get into. Why bring the work home? One of the biggest factors right now is transportation and transportation costs and the long lag time. We've seen in every recession since 2000 a 3 to 6 month bump in our shipping patterns because of this long lag time for product to go to Asia, be reprocessed or assembled into the products that are more familiar to you, like cell phones and computers, and then come back to the United States as those finished products. Labor costs are increasing. About 5 or 6 years ago, the first labor unrest started in China. And I was talking to somebody, I said, I don't understand this because I expected this to happen. I didn't expect it to happen until about this time frame. And the person said to me, internet. And I said, well, yes, you're right, you're a genius. You know, the Chinese, even though they may be censored, have access to more information. And so their desire for higher wages, this is a human desire for more. The Chinese and other people in the world aren't any different from us. They want more also. So it was only natural that their wages would increase. And that's starting to get to the point now where people are reevaluating whether low-cost countries really are low cost. So we also have higher productivity in this country in many aspects, and we also deal with the level of complexity in many aspects that other countries still don't have the technical skill and know-how. We're fortunate that precision metal stamping continues to be one of those areas where we have a slight technological edge because of the bending and forming of metal on very small components that we do. I actually have. Getting my clickers confused here. Okay, there are barriers, however, to bringing the work home. And those barriers are don't have enough machines, don't have enough skilled tradespeople. The work is more technically difficult, so it requires a higher skill levels now than it required maybe 10 years ago when the work left the country. So we also require new skills. A lot of the machining, a lot of the computer skills have evolved over the last decade. Also, there's a regulatory climate and an employment climate in this country, as well as a financial climate that aren't necessarily 100% friendly to business at this point in time. So even though there are opportunities to bring more work back and do more work, there are also a lot of barriers still to make that challenging for businesses, particularly small businesses. Reshoring is important because it's an opportunity for us to grow our company. Obviously, more work means more business means more jobs, and ideally we should be able to translate that into profitability. It's more money for us. So therefore, reshoring strategy, how to tap into this trend, is very important to us as a business at this point in time. Now, one of our strategies that we believe is important to this whole reshoring effort is when we looked at the issues. Transportation was a big issue, and low cost was a big issue. So we looked at different manufacturing models, and we started this back in 2000, 2001. And we said, well, what we need to do is become better at what we do, and what does better really mean? In our world, better started to take the appearance of what we call velocity or speed. What we wanted to be able to do was focus on the flow of work and not the traditional manufacturing approach of manufacturing efficiencies. I don't use the word efficiency very much in conversation about our business at this point. We talk about effectiveness and we talk about the flow of work. And this is consistent with what the concepts that might be very familiar to you are the lean concepts or the Toyota production system, and the theory of constraints by Eliyahu Goldratt. I don't know if you've read The Goal is a popular business novel that explains his theory of constraints. But the velocity perspective is consistent with both of these two teachings, where what we're attempting to do is simply speed up or accelerate the rate of manufacture. And a simple example of this is if I look at the top process, and it's very simple picture representation of the concept. If I have a batch and queue process, if I'm making plastic airplanes and I'm assembling these out of a number of parts, and let's say I have 4 different assembly stations to make those plastic airplanes and put them in a package till I have a finished good. And the batch and queue process, if I have 4 steps in the example in the black, what I'll do is maybe I'll make all the wings and put them in a pile, and then I'll pass them over to another group that's made all the bodies, and then another group will put the wings and the bodies together. But this will all be processed in a batch and queue manner, so that I have to wait to the end of the process to get my first group of airplanes. And you see there's spaces between each of these, and those spaces represent waste. In the lean language, these would be transportation. I have to move the units from one location to another. They may be inventory, work in process. Okay, I have wait time. In the bottom model, one-piece flow, what we describe this process as the stations are closer together, and we work on one thing at a time. We'll work on a wing and pass that wing. There's someone working on the aircraft body. They work on that body, pass it on. Then the 2 items are assembled. So I'll get one piece out of this flow at a much faster rate. I think on the graph here, it's almost half the time is reduced by working on only what needs to be done when it needs to be done. And I don't want to get into a deep discussion of velocity, but conceptually what we're doing is simply trying to eliminate all those wastes and accelerate a process by being more effective versus more efficient. The implications are that I may have machines that sit and do nothing for longer periods of time, but I'm not concerned about that as long as my work is flowing through my factory at a faster rate than it had been when I was worried about efficiencies. When velocity is achieved, we maintain quality. There's no degradation of quality. We increase capacity, and we can increase output. Typically, your capacity increases first, and then you need to fill that capacity with sales in order to increase the output. And you eliminate the transportation issues. So if we go back and talk about some of the reasons for reshoring, we see that a velocity strategy plays right into reduction of costs and also acceleration of speed and reduction of transportation or elimination of transportation issues. Now, Dytek is a manufacturer, and our #1 goal is to make money. Sometimes that's a dirty word, but this is a business group of people, so it's okay for me to say that we like to make money. Okay, and we prefer to make a lot of it. That offends some people in the community, so we have when we go public, we talk about stamping ideas into reality. It's the same thing. If we're successful at stamping those ideas into reality for our customers, we'll make money. Let me get caught up on my other side here. We make that money, or we stamp those ideas into reality by leading our customers to success. We help our customers engineer their products. We also engineer and design the tools of manufacture. We're working in a custom environment with a very small precision metal stamping. I can show you pictures of some of the product we make. Over here in the middle one under medical electronics, that's a thumbnail. to give you a sense of the scale of the products that we make. Everything we make will fit in the palm of your hand. It's very intricate, complex work, and not only do we have to manufacture these individual products by the millions. A typical week for us, we produce anywhere between 10 and 30 million products. In the 1990s, we did the edge clip connectors for the IBM Power PC. We produced 70 million connectors a week simply for that program. In that era, because of the style of stamping we were doing, it would be typical for us to do 100 million parts in a week. So you can see that adds up to billions of parts over the course of a year. All of it very small, all of it very intricate and detailed. We do it for a number of different market segments. You can see up there. The goal, I joke with a lot of people on my staff, and I say our real tagline should be that you can't make it without us. That's our goal. Whether it's your automobile, your cell phone, your computer, anything that is electronic in your world that has a thinking device in it or a component, pacemakers, IVs, you can't make it without us. One of my goals is to someday, if there were a person that looked at their supply line closely, they'd say, oh my God, if Dytek had a disaster like they did in Japan with the reactors, we'd be out of business for 3 or 4 months until we could rebuild dies and manufacture that replacement product. That's how pervasive we attempt to be in certain industries. So, if we look at the environment, we're one of about 2,000 North American stampers right now. 2,500 have disappeared since the 1990s. There were at least 5,000 stampers in the 1990 census, organizations that classified themselves as precision metal stampers. And over the last 2 decades, 23 years if we're more precise, the estimates are at least 2,500 of them, maybe more, have disappeared from the landscape. That's partially due to environmental conditions as well as the outsourcing phenomena and the way that work has changed and levels of organizations have changed. We do typically $8 to $10 million in annual sales in an industry where the typical size is 4 to 5 million. So we're larger than the average company. We have a staff of 32. We have a revenue per employee of $281,000. And the industry, again, typically is $180,000 per employee. Our exports are greater than 50% of our revenue at this point in time. We export to Canada, Mexico, Brazil, the Middle East, Israel, Greece, England, Scotland, China, the Philippines, all over the world. We've been fortunate that our products are light enough and technical enough that we've been able to continue to take advantage of our ability to make products that people need to assemble their products. And this is not typical for our particular industry at this point in time. And what this is an indication that we've been successful in our strategy of creating this velocity environment. We are a custom job shop, and again, the work is very complex, difficult, has a lot of forming, engineering, prototyping, and development associated with it, which are typically time-consuming, expensive, difficult processes. We also deal with fluctuating demand. If you think of that supply chain that extends to Asia and then back to the United States, if somebody at Christmas time, imagine, was it the popular thing this year was probably sold out in early November or at least early December. And so the response time then to replace goods on that shelf, when you have a long supply chain, you might not replace those products on the shelf until January or February. And so people are forced to purchase alternative items that maybe they didn't really want, but I need a Christmas present, so I have to buy that now. So it's hard for a long supply chain to deal with those fluctuations. A shorter supply chain or a quickly reacting supply chain can deal with those fluctuations. And typically one of our issues is historically the industry has very long lead times to produce our products. So it's one of the challenges to create velocity is how do you reduce lead time. Some of the other conditions are this industry is in contraction, as we talked about. I'm losing my place again. The industry is in contraction. The industry is also dispersed, with the average size of a company being around 4 to 5 million. The metal stamping, particularly in our segment, is we estimate at least $50 to $60 billion worth of stamped products annually. So the industry is extremely dispersed and exists at all kinds of different levels in captive organizations as well as independent ones like ours. And the production is highly automated. This has been a big advantage for us in being able to export and keep costs down, the fact that we are heavily automated. And again, our manufacture of the means of production, tools and die work, is slow, inconsistent, and expensive. As we've worked on our competitive strategy, which has kept us in business for the last decade, operational excellence, utilizing theory constraints, lean concepts, and developing the strategy of being quick to market or developing speed, we began to notice that there were a number of issues that went along with this that helped us be more competitive. The first was that we were able to fulfill customer needs and wants quickly. How many of you want to wait to buy something? If you want a new car or a new computer, do you want to wait 6 months to buy it? No. You want to go online or you want to go to a store, you want it now. So that culture exists in business. Everybody wants it now. We're also able to reduce operating expense and increase throughput. And it reduces the time required to do our work. And one of the things that began to concern us and we started to look at as we increase the velocity of our products, it also has to accelerate our rate of internal improvement. It has to accelerate our rate of innovation and has to accelerate our rate of learning. In the metal stamping industry, this is like, oh my God, what are you talking about? You want us to learn faster, you want us to improve faster, you want us to innovate faster. We have a time-honored tradition of that I always say, build no die before it's time, which means we'll take all the time in the world to build a die so everything's perfect, precise, correct, and right. And we just don't have that luxury anymore. Part of the process has to be, what do we really need, get that done, and move on to the next project. All of this adds up to velocity. We set several measurable objectives when we started down this journey. There's a quick list here: on-time delivery, scrap, inventory reductions, inventory turns, cycle time reduction, customer returns. These were all measurable and were good indicators of how quickly we were accelerating our business. And one thing that we found is that we got very consistent results. If we look at time, and this time span is years, imagine this being a decade. This is this century, 2000 to 2013, and just plug any of those measurables into the quantity axis. We saw this pattern emerge over and over again with our data, that we have a metric that's running out of number, we make an improvement, scrap, and it would drop. We make an improvement, scrap, and it would drop. When we started at the turn of the century, our scrap rate, which is one of our benchmarks, was an average of 3%. And it's like, wow, that's really good, because it used to be like 10 or 12%, in the bad old days, before my time with the company. And the idea that you could reduce scrap from 3% to something lower was akin to saying the world is flat, okay, to all of you in this room. At this point in time in 2013, our scrap rate is 0.3%. So we've gone over a decade from 3% to 0.3%. That's the difference in about $250,000 in scrap every year to about $20,000 in scrap in real dollars between then and now with the type of work that we're doing. So it's rather significant. But it begged another question, is why is this pattern so pervasive? Why do we see this pattern all the time? Why don't we see a different pattern? What's going on here? And it piqued our curiosity. And when we examined our data more closely, we realized that at these points where the red arrow is, at the point where there started to be change, we had done something different. And what we had done is changed a policy or procedure, and these yellow columns, which try to represent that curve from the top of the stair step, if you will, to the next level of the stair step, was the amount of time it took the organization to train and adapt to that policy change. And then when we looked a little closer at it, I said, well, gee, if we look at our rate of change or improvement, we see these big gaps. Why do we have these gaps? Well, it's back to our batch and queue looking process, not a velocity looking process. Why is that? What can we do about it? And we weren't sure. And I have a slide to help compare these side to side. If we go back to our theory, our batch and queue process versus our velocity model, what we desire, we see that the reality matches the batch and queue much more than it matches a velocity process. So we're losing speed in our ability to improve and our ability to innovate. And why is that? What can we do with that? What happened was about 2 years ago, I was introduced to the research of Elliott Jaques. The big question that Elliott ran into in the 60s was somebody asked him in a union environment, they say, why do managers get paid more than workers? Elliott said, that's a really good question. And he spent a year or two researching it. And at the end of his research, he said, well, pay is based on the ability to manage complexity to get a result over longer periods of time or over longer periods of uncertainty. And that's the basis for differential in pay. That was interesting enough on its own, but Mr. Jaques, or Elliott as I call him all the time, went further. And he said that humanity can be classified by the ability to successfully do work, and that is get results over time. That the greater the ability to get results over a longer time equals a higher stratum. And what he proposed is that, like the layers of a cake or the layers in the Grand Canyon, that we all have certain levels of capability. And that capability is dependent in what he called a requisite organization. A requisite organization has to have all the layers right. Okay, when in more modern parlance, if you're familiar with the work of Jim Collins and his book, Good to Great, he talks about right people in the right seats on the bus. What he didn't help us with was, well, how do you define what those right people look like? And how do you get them in the right seats on the bus? What I thought was interesting about Elliott Jaques' theory is that he helps you understand a definition of what the seats look like and who can properly fill those seats. And the theory of stratum helps us understand that. So if I look at a little bit more detail in his work, he talks about time spans, that the first layer has a time span of productivity of about 1 day to 3 months. The next will be 3 to 12, and the next layer is 12 to 24 months. He looks at the typical roles that people fall into with these capacities, and those are production roles for Strata 1, where people do the actual work with machines and tools. These, in our world, are our tool and die makers and our press operators. All right? And one of the comments that you'll often hear these people make is they enjoy the steady rhythm of the work, that there's a certain pace to that that work that they enjoy and find comfort in. The next level is supervision, which its tools are schedules and standards that they use to measure work against and measure performance and output. Okay? And then there's the third level, management, which deals with policies and procedures. And they're the group of people that set up the rules of engagement, I call it, is how the business works. If we look over at the problem-solving strategies that we use, we see different strategies evolve also. The first level uses pretty much trial and error. If something doesn't work, we'll try something different. If that doesn't work, we'll try something different again. The next level works with experience. After I do so much trial and error, after a while I have some experience and I know, well, that won't work that way. You know, I need to do something different. And then the third level actually does root cause analysis. Now each level builds upon the next, all right? And each level is important. But when we looked at our data, one of the questions we had was, if root cause analysis is at those arrow points in the process, is this where the work's getting done? And let me get to that point again. So the arrows, we said before we did something different. Those were the point of a policy change. So it may be difficult, but if you can imagine that in an environment where I have tools that require a certain level of maintenance and upkeep and troubleshooting to keep them operational, and my experience is I have these experienced, very skilled people working on making those tools run, and their job is to keep them running, but they're also engaged in this constant and consistent churning to make those tools consistent and run. They're at one of these levels at this point in time. And then at some point, a manager or a person with this, and it may not be a manager, they may be an outside consultant, someone with this root cause analysis ability comes and looks at the problem, and he sees the problem differently because he's looking at a higher level of complexity and looking deeper into the problem. He's doing what I call true root cause analysis, where we're really getting to the underlying issues that are keeping us from being successful. And then he writes a new standard or a new policy, new procedure to address that shortcoming. And immediately, we have completely different results from that point forward that are easy for us to duplicate with our die maintenance technicians. So what we really saw in this pattern was prioritization. If this was a priority, there would be someone eventually at a level 3 that would work on the problem, help resolve it with the input of our technicians and operators, because they're still part of the process. This isn't done independently, but then new policy and new procedure would be written. So this is great. All of our problems in manufacturing are solved, except for one small problem. Based on Elliott's research, when we look at the different stratum that are available in a population, he's estimating that only 4% between the ages of 21 and 50 are capable of essentially doing true root cause, effective root cause analysis. If we extend that to the age of 70, we get 7%. So a big implication, if we believe his work, and I do at this point because my experience seems to indicate that, is that we have a situation where we don't have enough horsepower to resolve all of our problems at the pace that we want to, at a high velocity rate, because they're fairly scarce in the environment at this point in time. That with only a 4 to 7% of the population with the capacity to do true root cause analysis, we're at a disadvantage unless we can identify and attract that type of talent to the organization. And again, with 32 people in the organization, how many of those people can you attract and afford? Because remember, in this theory, as we go up, since we're dealing with more complexity and more skill to get the work done over more uncertainty, that should equal higher pay, higher levels of pay. So One of the other implications is that there are a lot of people in management positions in our companies and in other companies that really don't have the capacity for effective root cause analysis. We were very guilty of this. We hire a fantastic operator. They do a great job on the press. They start working with dies. We move them up into a die maintenance position that's more skilled, it's more technical, and this is great. They say, hey, you know, I'm having a great time building these machines, now I want to start designing them. We send them to school, they become an engineer. They do a very good engineering job, but they don't have or haven't learned along the way, haven't had the experience to develop effective root cause analysis. And so we get results, but again, they're not at the velocity, they're not at the level of result, they're not the quality or effectiveness of the result that we want. So also realizing that these right people are pretty scarce, and also we realize from our data and our experience, unless we're really getting to true root cause analysis and finding the true underlying problems, we're just going to repeat and repeat and repeat and go through these tasks over and over again without being able to effectively move our performance benchmarks. So homework, if you will, since we're in a university environment, I guess I can use, that's probably a dirty word here too nowadays, huh? But my thought that I'll leave you with is, if less than 10% of the population has a capacity for effective root cause analysis, and effective root cause analysis is the basis of continual improvement and innovation, then how can our society increase effective root cause analysis capacity in the population? Okay, to me, this, when we talk about the skills gap in the country, right now people are talking about, well, we don't have enough nurses, we don't have enough lathe operators, we don't have enough mill operators, we don't have enough people trained to run CNC machines. I see the problem is deeper than that. That if we had more people that were effective at root cause analysis, would we need as many lathe operators, as many nurses? Will we need as many of the roles, traditional roles that we think of, particularly in manufacturing, that we need to do our work? And I would argue that if we continue to follow the concepts of lean and velocity, that this thinking work becomes the most important work of all, because it allows us to garner efficiencies and effectivenesses with our systems that we can't even imagine at this point in time. That the American manufacturing has increased its effectiveness dramatically in the last 3 decades. We've gone from, I forget what the number is, I think 30–40% of the workforce was employed in manufacturing. We're down to, I think the last number was less than 18% and still dropping. Yet we still are pretty much the #1 global manufacturer in the world. China's in a dead run in second place with us and is projected to pass us within the next 5 to 10 years. And they're doing it with a tremendous amount of labor. So the way that we can win the manufacturing war, in my perspective, is to be better at thinking. And so one of our tasks for society, for our country, is how do we develop better root cause analysis capacity in our population to help us meet the needs of the future. So in summary, the work's coming home. Reshoring works to our benefit. It's coming home particularly to those who understand velocity and how to use velocity to not only do the work that they have right now, but understand how to use velocity to innovate and improve. And that is a result of effective root cause analysis. And one of the biggest challenges we have right now is that we only have 10% of our population that is effective at it. And part of that population is past the retirement age. If we look at pre-retirement, it drops down to 4% of our population. So this is a serious issue, in my opinion. My question now is, what will each of you do to help resolve this problem and solve it? Tell me one thing that you'll do tomorrow in your life as a result of this lecture. This is where you get to give me feedback and help me understand if my message has been effective this morning. I don't need my glasses anymore. So any questions or comments, any feedback? Yes?
So do you think the problem is from an education standpoint or an experience standpoint as far as being able to have the capacity for root analysis?
That's a really good question. I don't know. And I'm not sure that Elliot answered that question either in his research. What he did indicate is that you're not locked into a stratum at any point in time. That it takes till about the age of 18, 19 to be able to discern what level a person is at that point in time. But he also indicates that at that point, you can also have the ability to start predicting what level a person will end up at. So if you were, say, at stratum 3, or indicated for that at the age of 20, one might expect that by the time you were 60 or 70, you might be one of these rare individuals that's exhibiting stratum 7 or 8 behavior. And typically, we would like to see people at that level in creating policy on a national or global basis. I think one of the other implications here is we have a lot of people in government that are not the appropriate stratum for the work that they have to do. They constantly deal with unintended consequences, that we make policy and then, oh, shoot, 5 years later, we didn't want that to happen, but that's, like the whole housing issue was the unintended consequence of loosening up certain regulations and changing certain policies. So the unintended consequence was a crash. So a person isn't locked into a band. You can grow and move up through the layers as you gain more experience. I think a deeper component of this question is what experience does a person need the ages from birth to 18 to begin to present at a higher level. If root cause analysis is what we want, we'd like to maybe be able to discern and see presentation maybe at an earlier age, maybe in the 10 to 12 range. But we don't know. It would be an area, the few of us that have been kicking this around said, boy, if somebody did research on what are the factors. Are you born with it? Is it learned behavior? It's probably a combination of both. What do you need to do to nurture that and grow it? We don't know at this point. Someone else? I'd like to point out there are a number of people that if you Google and start to get into his research, there are a lot of people that think it's elitist because you're categorizing people and saying they're stuck. And that wasn't Eliot's perspective on this. It was simply that by the way people work, we evaluate and judge people all the time in the work world based on their performance and the results that they get. And his perspective was that you can look at that and use that as an indicator of future performance and capacity for certain types of processing, mental processing or physical processing. And that does change over time.
Can I ask a question?
Sure.
So, based on what you're saying, what is the future landscape for how U.S. firms like yourself will compete in the marketplace? In other words, what's the basis that you all will compete with foreign companies going forward? If it's not based on efficiency.
That's a good question also. Right now, the model that we're using is operational excellence. which is just being more effective at doing what we do than everyone else. The reason that we've been able to, we've played both sides of the street at this point. We're exporting more than half of what we produce overseas because of the automation in our processes. We didn't have to deal with the labor component. All right, so that was a null. The outsourcing movement was largely to capitalize on, initially, on processes that required a great deal of hand labor. So they were labor intensive and needed lower cost of labor to be competitive on a global basis. So as those labor rates rise and the transportation costs rise, it's started to push a lot of those products back into this country, and typically ones that were going overseas where the labor rate really wasn't a factor to begin with. From my perspective, the only reason that you should be in a foreign location is if you're going to service that market, because it puts you in proximity to it. So what I see eventually is a leveling. I would expect a lot of our export business to start to taper off as the skills and expertise for the work that's staying in those regions stays there and the skills developed to do our work there. But by the same token, our work domestically should increase when people say, well, we have other strategies now that the labor cost and transportation cost negate the decision to be overseas. We should be doing it here. General Electric is my poster child and somebody I like to beat up a little bit. That what's his name, Mr. Immelt, was made the manufacturing czar to revitalize American manufacturing. In 1990, 5 or 6 of our major customers were General Electric. And at this point in time, none of our customers are General Electric because all those jobs were outsourced and sent overseas. And so now GE's discovered lean, which is a 40, 50-year-old concept, and they're going to build engines and refrigerators and washing machines back in the United States. And I think, wow, this is the leadership that the president selected to, help the rest of us. I'm a little nervous about what kind of help we're going to get from that corner. But I think there's a global leveling that's going to happen, and where we can innovate, because the product is fairly straightforward. Where we can innovate is how we deliver and interface with our customers in the engineering aspects. And I think personally our company evolves into more of an engineering firm over the next decade or two, rather than just a means of production, which is essentially what we are right now. We go deeper into customers' processes and procedures and work with them closer to the idea phase of their products, rather than getting a print and then saying, here, make this for us. We're starting to see that in our relationship in the automotive industry in lighting. They sent us a design last winter for a terminal, and we said, why are you making it that way? And we've done this a lot over the years. He said, well, that's the way everybody makes it. And there are a whole bunch of technical factors that made that part difficult, expensive, and not as reliable as they wanted. And said, let's change this and do this to it. And it's like, oh, wow. So we changed that. So far, they're happy with it. We'll probably go into production, that particular product, with this radical design. So what did we get last week? We got another terminal with the same old feature in it. So it's a constant battle. It's like, we made this design change on that product. Why don't we translate it over to this product also? It's like, oh, we didn't think you could do that. It's the capacity to analyze and fit the patterns together that, what I find is just because somebody's an engineer doesn't mean they have that capacity. It's entirely capable engineering work without good root cause analysis skills. So does that help answer the... All right.
Any other questions? Okay, we everybody.
All right, thank you.